I think it's not tricky, but I think it's the first time that you all need to do analysis. Okay, as I say, it's not tricky, but it's the first time you are required to do analysis. Okay, right. So this question is determine the maximum normal stresses developed on the cross section. Okay, we're just looking at normal stresses, and when you look at a structure, it's a bit like, whoa, what are we looking at, right? So the first thing for this case, what we need to do is we there's no transformation given. You decide what transform what are the values of the transformation. Okay. So I'm going to call this my x. This axis is my y, and this axis is my z. Okay. So when you look at a structure like this, I'm going to sketch green lines. Green lines are so-called the centroid. So this is centroid. And then I'm going to sketch another line. Yeah, they're the centroid. And you realize that there's a moment, right, in acting in this direction. Right? And the moment about x is equal to 2p multiplied by a distance of 0.25. Can you see that? So it's the 100 plus 150, so you have the 2p. So that's moment about x. Then you have another moment about y. And the moment about y, right, is p multiplied by 0.075. That's moment about y, right? You can visualize that, yes or no? Okay, so you have two moments and you have two vertical load. Okay, so the formula that you know that you need to have is stress Z is equal to plus minus PZ over A plus minus mx over ixx multiplied by y plus minus my over iyy multiplied by x. Okay. So we are aware that this is a eccentric unsymmetrical bending. Okay, we are make aware of the case. Okay, and we are asked to calculate the maximum normal stress. And this is a bit like the question everyone asks: maximum normal stress about where? Yes or no? Right? And a thing to take note is there's only one normal stress that we are very sure. This term over here is always going to be what? Negative. Regardless of what point you look at, Okay, regardless of what point you look at, that term over there, the PZ over A will always be negative, right? And depending on which point we look at, this can be plus or minus, this can be plus or minus. Okay, so now what we discovered is the maximum normal stress will be what? Will be compressive.
When they're
Okay, and maximum normal stress will be compressive. Okay, so now I'm going to call 4 points. Okay, this is my point A. This over here is my point B. This over here is my point C. And this over here is my point D. Okay. Why I pick point A, B, C, and D? Because they have the maximum X value and maximum Y value. I repeat again, we pick A, B, C, D because it has a maximum X value and the maximum what? Y value. Okay. So now, let's look at moment about X. Okay, so moment about X will be equal to what? Will be equal to P, which is 60 times 10 to the power 3, multiplied by 0.25. So let me check. Okay, here, and then it's going at 100 0.25. So this will be equal to 60 power 3 times by 0.25. Turn on the calculators. Is equal to, wait, is it 0.25? 60 power 3 times by 0.25. Wait, did I?
Isn't it also times by 2?
Oh yeah, 60 power 3 multiplied by 2. You're right. I missed the 2. I wrote the 2 there. I forgot to put the 2 there. So
Also,
mx.
why do we not set points C and D at the rightmost ledge? Wouldn't the Y value be larger there?
You mean the, now, the structure, it refers to the entire I-beam. Excluding.
Oh, okay. Okay. Excluding the right side. Got it.
Yeah. So 60 power 3 times by 2 times by 0.25 is equal to 30 times 10 to the power 3 Newton meter. Okay. So when we see mx, we know that mx, if we draw this in 3D, is going down this way. Okay, so this is mx. So this is compression. On the left side is our tensile. And then if we look at my, my will be equal to 60 times 10 to the power 3 multiplied by a distance of 0.075. It's equal to 4,500. And for this case, this is your moment about Y. Okay, so over here, this is compression, and this is tensile. Okay, so now, now we are going to focus on point A, B, C, and D. If we look at P over A, right, all will be negative. If we look at my over Iyy multiplied by x, okay, So my, point B and D are negative. Point A and C are positive. And then when we look at mx over ixx multiplied by y, number of x, point C and point D are negative. Point A and B, okay, mx, point A and B are positive. So because of P over A is in compression, it controls the maximum value or maximum, it controls the maximum absolute value. Okay, so this case, we are going to investigate what is happening at point D. And half the battle is already won. When I say half the battle is already won, we know PZ, we know MX, we know MY. Okay. Next, we only need to find our IXX and our IYY. Okay. So we look at our IXX. We just need to be careful over here. So XX, so the width is equal to 0.2. Okay. The depth is 0.3 cube divided by 12. So this is a solid rectangle I'm taking. Okay, so this is a solid rectangle I'm taking. Then I'm going to minus the two sides. Okay, the two smaller sides. And then we also have the what? We also have the I, right? We don't need to find the centroid for this case because we know where the centroid is. I repeat again. We don't need to find the centroid is, where it is by using the formula. Remember, I showed you guys before, because we know where the position is by just doing observation. Okay, so twice the width is equal to 100 minus by 75. Okay, 100 minus 100 minus by 7.5 is 92.5. That's the width. And the depth is 300 minus 15 minus 15, 0.27. Okay, so this will be equal to 3 power 3 divided by 12, 450 minus 2.5, 92.5 power minus 3 times by 0.27 power 3 times by 2 divided by 12 is equal to 303. Hold on. The width is 100 minus by 7.5, 92.5, correct. The depth is 150 minus 15, 300 minus 15 twice, 270. So 0.27 power 3 times by 92.5 power minus 3 times by 2 divided by 12 is equal to 303.446 times 10 to the power minus 6. So 450 power minus 6 minus by 303.446 power minus 6, I get 146.554 times 10 to the power minus 6 meter to the power 4, right? Then we find our IYY, right? So YY, so it's twice. The width is 15 or 0.015. And the depth is 0.2 cube divided by 12. So that's the left and right pieces. I want to be sure that I got the right value. Okay. So IYY, the width is equal to 300 minus 15 minus 15, 0.27. And the depth is 0.015 to power q divided by 12.